how opposite poles attract, and north magnetic poles never exist without a south pole, and vice versa.
Good.
Okay, you need to know what that says.
Okay, Caden's got it. I have faith in Caden this time.
So what?
I have faith in you this time.
You have to rattle that?
Well, you should know what these things are, yes. Oh, life is so hard for Caden. He's got to use his fingers to write the words. Oh, I'm recording this, so that's going to be on there. That'll be online. Anyway. I know somebody's going to be like, "Oh, you shouldn't post this kind of stuff." Ah. Yeah, that's right. I'll leave this up here, but I may have forgotten to record when the other stuff was up there. So I'm putting the other stuff up here too. So the questions about what magnetism is, about how the poles interact, and then this key thing about monopoles. Monopoles don't exist. Let's see, we go until 6, right? We'll get started on the next group. We'll get started on the next group.
Dang it!
Yeah.
So, I did the dumb line. Okay. So, I was experimenting with time. So I did these, but for every section except the R.
And you were the one supposed to do the question? Yeah. All right. Well, just I'll post the reading on Schoology. Just do it tonight. Okay. Here you go, Sarah.
And Mr. B answered that for me. It was, field is static, not moving, and what did it even say?
Being aligned.
Being aligned.
Well, you wrote being aligning, which makes no sense. But being aligned is what you should have written.
Being aligned.
All right, so iron filings. So he was asking, like, the iron filings, when we did the lab, they don't travel with the field. So why don't they do that? They just get aligned. They get lined up. And those are called, the name for this is magnetic domains.
Oh, my big head is my
Now can you see?
It is not. You're a liar.
I swear.
My liar things.
I don't see your pencils hard enough. Is that better?
Secret.
All right, and read the second one, Chase.
And then my second question one is, how is electricity related to magnetism? And then Mr. B also answered that for current products. Current produces a magnetic field.
Yeah, Mr. B!
Woo. So I thought that Chase was doing the clarifying, because his are good clarifying questions, but they're not very good questioning questions. So I'm going to add a few things. So let's start off with... I'm a hater.
He uses 2 in 1.
So, what is a magnetic field?
Oh, that was probably the easiest one.
Yep.
It's a field of magnetism.
So, magnetic field is an area around a magnet that can feel a magnetic force.
Like that.
That was a bad joke. Brown practice. For when I'm in my full. I was going to say. No, I'm not practicing.
Okay. Oh, the two of you might want to write these down since Chase did you a
I'll take a picture.
did you a not he did you a not solid.
Alright, go
Alright,
back on
guys.
strike.
I did liquid.
I see what you did
I
there.
see what I did.
Yeah. All right, so that's the first thing. What direction does the field go? So what direction does the field go? Field go. It goes from north to south. But Mr. B, when we used the compasses, it pointed to the south. It didn't point to the north.
Yeah, what the heck?
Like when we put our compasses point north, but you said it goes from north to south. So why would it point north if it goes from north to south?
Why?
Huh?
Why would it point south?
Yeah.
Because that's the direction that the...
Because it's not a North Pole. The North Pole is not a North Pole. The North Pole is a South Pole.
Santa's not real, guys.
Whoa! He said that on video.
So
What are you doing?
What are you doing, Chase?
that's right. Tons of small, impressionable children watch this, like you.
I just ruined it for myself.
I know. So we'll get to this with the group that does the Earth's magnetic field, but it always points from north to south, which will help explain compasses a little bit. Let me get one more thing, and that is, what are magnetic domains? Yeah, you can write in 2 minutes. That was probably a bad decision. All right, so last one. Hold on, guys. Sit down, sit down, sit down. What are magnetic domains? So magnetic domains are regions of aligned atoms. So they're regions in a magnetic object where all the electric fields line up. So you get a bunch of these magnetic domains, and if they all point in the same direction, they're magnetized. So in theory, you could magnetize yourself.
What?
If you could line up all your magnetic domains, you could, in theory, magnetize yourself. So the idea of magneto is not actually that ridiculous. If you could control your magnetic domains, you could make yourself magnetic. So you could produce a magnetic field.
Like when I eat all those.
Is that what happened?
Yeah, like when you eat all those iron filings, yeah.
Is that like...
Can I take my paper back?
Yes, you may.
Thank you.
Wait, let me take a picture.
I better set